Hello everyone, my name is Nachamon Sukontametirat from Suvarnabhumi University of Technology, Thailand. Today I will present about the isothermal crystallization and some rheological property of linear and band isotactic polypropylene. First, isotactic polypropylene or IPP is a typical semi-crystalline polymer that has become one of the very used in industrial and commercial applications. It has many desirable and beneficial physical properties such as the low density, high melting point, and chemical resistance. Usually, polypropylene has three structures, but in this work we interested on the isotactic polypropylene, which the side chain group is methyl, stay in the same direction. However, the commercial polypropylene usually have relative low melt strength and exhibit no stain handling behavior, so these limit their use in applications such as the thermoforming and blow molding. So, to improve some property of PP, the 1-butene defect with a few percent were added to IPP homopolymer to improve the property, such as improve higher the impact strength, high transparency, and high processability. But in this project, we don't synthesize this copolymer by ourselves, but we obtain our sample from the Sinopec company from China. We have three code names. First, V30G, this is the linear IPP, and the MT series have two samples, including the MT12 and MT18. So in this work, we want to investigate the effect of short band or 1-butene defect on the isothermal crystallization, phase morphology, and some rheological property of linear compared with band isotactic polypropylene. And this method we use GPC and MAR to characterization the sample information. Then we study using by the DSC, synchrotron SAXS wax, and for the rheological property we use EMA and rheometer. This table shows the sample information for all of three samples. The molecular weight has the similar length around 200,000 grams per mole. And when samples have defect, the melt flow rate decreases. And when compared with the MT series, the code name of MT12 has percent 1-butene about 6%, and the MT18 has 5%. To study the isothermal crystallization, we study by the DSC. So we heat sample to 200 degrees Celsius and hold this temperature about 5 minutes. Then we vary the crystallization temperature 5 temperature between 125 to 135 degrees Celsius. And it found that both the height of the crystallization peak and time decreased as the crystallization temperature increased, and the time to complete crystallization also increased with the crystallization temperature. For more analysis, we choose one temperature at 130 degrees Celsius to calculate the degree of crystallinity to compare for all samples. For IPP with 1-butene defect, the crystallization isotherm will shift to shorter times, indicating that the short band defect can accelerate the crystallization of IPP. And the induction period and final degree of crystallinity was decreased. So, from these results, the VT0G has higher degree of crystallinity when compared with MT series. And the overall time was significantly longer. Next, we use a Abami model to calculate the K and N parameter. K is the crystallization rate constant and N is Abami exponent represent to the dimension of growth crystal. In the early stage of crystallization, the Abami exponent or N for all samples are in the length of 2 or 3. This suggests that the crystal growth have 2 or 3 dimensions. For VT0G, the crossover behavior was not observed because N in the larger state did not change. But for the branch sample, N was decreased in the larger state. This suggests that have changed in the mode of crystallization. And when we look at the K parameter, the VT0G has the lowest crystallization rate constant. For SAXS experiment, first, the specimens were melted at 200 degrees Celsius about 5 minutes. Then the sample cell was quickly moved to another heat block, which maintained at 130 degrees Celsius, and the time resolved measurement for SAXS and wax were performed. This figure shows the low-length collected SAXS profile. The VT0G has the highest intensity, so this profile can tell about this sample has the crystallinity higher than the MTCD. The more analysis, we want to calculate the lamellar parameter by the electron density correlation function. This function can be derived from the inverse Fourier transform of the experimental scattering intensity. This method can be used to determine the information of polymer morphology, including the long period, lamellar thickness, and amorphous layer thickness. So from this curve, we can calculate the long period from the top peak of this position and LC in this intercept. And D or L long period is the area covered with the crystal and amorphous phase, and L is area of crystal phase and A is area of amorphous phase. Next, we will talk about the structural parameter. We talk about the long period first. Long period or D of MT series has the value larger than the VT0G, and when we compare between these two branch samples, there is no significant difference for their D value. Then the lamellar thickness or L increases with time, suggesting that the lamellar growth can be confirmed for all PP samples. The overshooting phenomena of the growth in the L show in the PP with defect. The L reaches a maximum and then decreases due to future annealing. So it is important to check the ratio of the L per D of the lamellar thickness to the long period. This ratio seems to be the crystallinity in the stack of the lamella, and in the black line is VT0G exhibits the highest ratio, which is obviously much higher than those of MTCD. So the one routine defect affected the crystallization of PP and decreased the crystallinity. For the web result, you can see in the sample with defect has more peak at this position, and this position is the gamma plane. So when sample have one routine defect, they can occur two in form of alpha and gamma. And we compare the degree of crystallinity in the wax and the SC. For the wax, we following this equation. AC is the summation of peak area of crystal phase and AA is the amorphous phase. The trend of the degree of crystallinity for both techniques is the same. The V30G has higher percent of crystallinity when compared with the MTCD or sample with defect. Then we study the mechanical and the rheological property. For the temperature sweep is the most common DMA test used on the solid material, and the frequency sweep generally serves the purpose of describing the time-dependent behavior of sample in the non-destructive deconformation range. For the DMA result, EPAM or storage modulus is measure of the sample's elastic behavior or tell about the stiffness. When adding one butene defect, the stiffness will decrease, and E double palm is loss modulus. E double palm is energy dissipated as heat with represent the viscous portion. In the low temperature, MT18 as E double palm higher than VT0G, but the VT0G will have higher E double palm in the high temperature above 50 degrees Celsius. And the ratio of E double palm to E palm or loss to the storage is the tan delta. When at the 1 butene defect sample increase the tan delta, indicating that the sample has more energy dissipation potential. For this result, G-palm is storage modulus represent the elastic portion of viscoelastic behavior which describe about the solid state behavior. And the loss modulus or G double palm represent the viscous portion of viscoelastic behavior which can be seen as the liquid state behavior. When adding the 1 butene defect to PP seem to very slightly decrease in G double palm, especially at the low shear rate, but almost no change in the G double palm. In addition, the shear viscosity is noticeable increase. For this table, when compared with the similar maximum load of 3 samples, the strain and state are different values. Strain is the ratio between the deformation and the original length, and state is the force carried by a member per unit area. The strain and state of V30G are the lowest, and the values are not different for the sample with defect. So, when adding 1 butene defect to PP, the sample has better state of the material. So this word can summary that the 1 butene defect accelerates the crystallization process of IPP and decrease the percent of crystallinity. And both of crystalline and the long period in the PP with defect are increased, but the ratio of alpha D is decreased. And the short band defect in the solid form are less stiff and their melt have larger melt viscosity. So in this work, we would like to thank the Chinopac company for the sample of PP and the IRPC for the measurement in the some technical. Thank you for your attention.